Okay, we had a lot of people struggle on these assessments. We need to watch this video here, okay? You need to let me know on stuff that doesn't make sense, okay? Because we had a lot of grades just drop. I'm not blaming the kids. I'm not blaming myself. It's probably a combination of the two, okay? Just that's in the past. Let's get better on it, okay? Some of you I did call back to my desk was maybe a little crabby, okay? Apologize for that. That's not going to solve anything, okay? And there's more than a couple I did that too, okay? All right, so we did okay on this part. Finding what a logarithm equals, you're just finding log base 3 of 81. You're finding how many 3's multiply to 81. That takes you to 9. Now you're at 27. That's 81, so the answer is 4. How many 7's it take to multiply to 343? So there's 1. That's 49. And 7 times 7 times 7 is 343, so it takes 3. Okay, when you got a 1/4, the reciprocal of a whole number, just figure out how many 4's it takes, but it's going to be a negative answer. So 1, 2, that's 16, so it'd be negative 2. Okay, 1, 2, 3, 4. So that takes 4. Okay, now we started to struggle on these ones. Both these problems, you're finding out what the x equals. Now, when you see an x power, okay, because x is part of the exponent, you're going to do a lot better if you circle the base and the power, just like that, and then split it. Okay, on this problem I have 2 different bases. This one I only have 1, so how I do this is going to be totally different than how I do this. Okay, when I have 2 different powers, what I want to do is try to get the bases to be the same on this graphic organizer here. So I've got a base 4 and I've got a base 64. Okay, so the idea would be to see if I can write them both as base 4's. Okay, see if I can write 4 and multiply it to 64. So there's 1, 2, 3, and that's 64. So I can replace that with 4 to the 3rd power. So I'm going to replace 64 with 4 to the 3rd and put the power that was already there. So parentheses 3x plus 5. And the other one, I just keep it base 4 and keep it 3x minus 2. So those 4's can be eliminated from the equation because anytime I have the same base, they can be eliminated. And then I can just say, okay, so 3x minus 2 is equal to 9x plus 15. Okay, so I want to get the x's together, so I'm going to subtract 3x from both sides. And negative 2 equals 6x plus 15. And then I undo the adding of 15. So negative 17 equals 6x. And then I divide by 6. That's going to be you can leave it negative 17 over 6. Or you can divide negative 2.83 repeating. Okay, now, if I only have 1 power, I don't need those glasses, okay? I'm going to set up blank equals log divided by log. So the exponent, the whole power, it goes on this side. And then the log of the 5 is on bottom. And then 130 is on top. So I need to find out what that division equals. And you go right to this. If you don't have anything multiplying outside your circle, which is why you draw the circle, you can go ahead and set that up. So that's 3.02. So 3x plus 2 equals 3.02. And then I minus 2 from both sides. So 3x equals 1.02. And then I divide by 3. That's going to be 0.34. So if you have the power on both sides, you need to use your sunglasses thing. If you have it just on one side, you take whatever power you have and set it equal to log over log. The log of the base is your denominator, and the log of what it's equal to is the numerator. Okay, graphing exponent functions. Okay, as soon as I see this, x power. Anytime I have an x power, I'm going to take out the plus 2 and just put minus 2 over here. And I know that any graph with an x power is going to have an asymptote. Okay, and how to find the asymptote? Just input numbers, positive 2, positive 1, 0, and then negative 1, negative 2, and then the asymptote is going to be the negative 10. Unless that base 3 would have been a fraction, then I would have done the negative 2, negative 1, 0, 1, 2, and positive 10, but we had a whole number there, so this is what I set it up. Now it's just plug and chug. Negative 2 times 3 to the second power plus 5 is negative 13. Negative 2 times 3 to the first power plus 5 is going to be negative 1. Negative 2 times 3 to the 0 power plus 5 is 3. Negative 2 times 3 to the negative first power plus 5, 4.33. Negative 2 times 3 to the negative 2 power plus 5 is 4.78. Then I'm going to plug in negative 10. Heck, you can even do negative 20 if you want. The result's all the same. You just get really close to 5. You won't ever get past 5. So the asymptote's positive 5. No, so the asymptote's anything that's being added or subtracted there. Okay, now I need to go back and minus 2 to all my x's. I need to undo the plus 2. So 2 minus 2 is 0, negative 1, negative 2, negative 3, negative 4. I'm not even going to graph that, so it doesn't really matter. So I'm going to want to count by 2's. Get your asymptote first. So 2, 4, 5. That's where you make your asymptote line. I want to see that, please. So 0, negative 13, 2, 4, 6, 8, 10, 12, 13. Negative 1, negative 1. So I go left 1 right there. I'm still going by 1s on this, but 2's this way. Negative 2, 3. So left 2, 2, 3. And then all that's going to happen is you're just going to get closer to your asymptote line. Okay. Okay, there you go. Now what I had the big problem was with the story problem. So what I'm going to do on these 3 is decide which ones I have a formula I can just write and which ones I don't. So a town's population has 30,000 people. It's increasing at a rate of 3% each year. How many years will it take to reach 40,000 people? Okay, I don't see compound quarterly at all, so I don't have a formula that I can just write. So the smart thing would be draw your boxes. That's the best I can do. Okay. I'm going to go back and solve it after I look at the other 2. I deposit $4,000 in a bank account, earns 3% interest compounded quarterly. How much will the account be worth 4 years from now? So this one I do have the compound quarterly. So beginning multiplied by 1 plus your percent over 4. I'm going to make a little note to that percent. Don't add 1 because the 1's right there. And then the power is your 4 times the years, and then the ending amount. Okay, and then number 10, price of a bread has been increasing at a relatively constant percentage each year for the past 5 years. The bread costs $1.19 5 years ago. Now it's $2.29 per loaf. Calculate the percentage rate of increase. You don't have compound quarterlies, so you better make your 3 things. Now go back to number 8 and let's figure it out. Okay, how many years? So the years is the answer to the problem. Units would be years and people. X is the years, Y is the people. People per year. Because on this problem was a commonly missed one because you went to a formula that you weren't supposed to go to. People per year, it's a 3%, so plus 3%. Anytime we have something changes by a percent, it's an exponential function. It's a curve. So I've got my beginning, and then I will be timesing by what's called the growth factor. And since that multiplication is repeated, it's to the x power, and then y up top. Okay. That's all you got to know how to write. Okay, your beginning amount's 30,000. And you will be, I'm going to circle that, and then from there I times. But now I want to take 100% and add the percent I was given, so plus 3%. So that's how I get 103%. That's how I get 1.03. Okay, now I can write the equation. I have 30,000 multiplied by 1.03, multiply, not add. You don't take, you multiply by percents, to the x power equals y. Okay, and then I've got 40,000 people. That's probably needs to go in here somewhere. And people is y. So it goes in for y. Okay, the x is a power, so I circle the power and the base. There's only one power, so whatever the power is equals log divided by log. We know 1.03 is the bottom, but the top I don't know because we have a multiplication of 30,000. And also, guys, this is a multiplication. The opposite of multiplication is to divide, not subtract. Take 40,000 divided by 30,000. That's 1.33 repeating. That's going to give me my answer. I got 9.64. It could be 9 or 10. Okay. Number 9, okay, number 9, I had a formula I can just write out, okay, the beginning amount's 4,000 times 1 plus 3%, it's not 1.03, the 1's right here, so I need to divide 0.03 by 4, as we can see, and then the power is 4, and the number of years, which is 4. My ending amount is y. So get that cleaned up. You know, 4 times 4 is 16, and we can get rid of the parentheses by taking 0.03 divided by 4 and then adding a 1. So I have 4,000. Now that parentheses is replaced by 1.0075 to the 16th power, and then y. Okay. Y is the letter you're solving for. It's not a power, so you don't use log over log. It's by itself. So that means you can just plug this into your calculator. 4,000. You only use log over log if the variable you have is a power. Well, there's no variable in the power. It's just 16. Okay, $4,508 is the answer. Okay. Okay, now the last one. The price of bread has been increasing at a relatively constant percentage each year. And this one you're finding the percentage rate, so percent equals. So what are the units? Well, I see years as a time unit, and that's X, and then I have money as a Y unit, so that's 2 units. Dollars per year. Now it's a percentage each year, so I don't know the percentage, so that's where I write P%. So it's a percent, so again it's an exponential function. We have our beginning times by the percent, which is called the growth factor, to the X power, and then Y. Okay, now my Y begins at $1.19. Now what I do with my growth factors, I take 100%, but I don't have a percent. I know it's going up, so I write plus P. So when I have to add P, I change the 100% to one whole, okay? And I will put 1 plus P for my G in parentheses. Now I can write my equation. I have $1.19 to begin with, and then from there I times the operation is by the growth factor 1 plus P to the X power equals Y. Okay, now P is what I'm solving for, so the 5 years can go in for X, and then it ends at $2.29, so that goes in for Y, okay? Now I'm not going to use log over log here either because the power is 5. There's no variable with the power. I just got to find the P. But the P's in parentheses with a plus 1, and that whole parentheses is to the power. Whenever I have an entire parentheses to a power, I'm going to use my Q, okay? And I'm going to make my little box here with 1 plus P equals. So Q in front's going to have $1.19. It's going to be to the 5th power. It's going to equal 2.29. Now, 1.19 is being multiplied by Q. The opposite of multiplication is division, not subtraction. So Q to the 5th. $1.92. Now I find the 5th root of both sides, and we can find that on the calculator by taking 1.92 to the 5th to the 1/5 power. That's 1.14. Okay, now all you have to do is subtract 1, and 1p equals 0.14. Now you don't have to divide by the 1. 0.14 is your percent. It's 14%. Okay, that's that one. Now composite functions, we had problems on that one too. F of x was equal to 3 times x to the second minus 5. G of x is equal to 4 times x minus 3. Okay, so f plus g of x. Okay, so the plus, you make 2 parentheses with a plus sign, 2 binomials. F is 3x to the second minus 5, and then g is 4x minus 3. Now run through you have parentheses, but you can't do anything inside of them. You have an exponent, it just belongs to the x. Do you have to multiply or divide? No, because there's a plus sign between them. So really it's just adding and subtracting, so that's like terms. So x to the second's your highest, plus blank x plus blank. So x to the second I have 3. X I have 4. Non-x's I take negative 5 plus negative 3, and that's negative 8. Okay. And now I insert 5 into the expression, so I take 3 times 5 to the second power plus 4 times 5 plus negative 8. That's 87. Okay, now it's minus, same idea. 3x to the second minus 5, and then the g is 4 times x minus 3. Now with this minus sign, we make it plus, and the 4 changes to the opposite, and so does the 3. Okay, so parentheses, yeah, you can't do anything to them at this point. Exponents just on the x. Multiplication, division, nope. Whenever you have a plus sign in between them, you don't do any rainbows, none of that stuff. Then adding and subtracting. So that's where I draw out my spaces, x to the second, x, and that. X to the second's 3, x negative 4, and then I take negative 5 plus positive 3, and that's negative 2. Okay, and then I insert negative 2 in for all the x's. So 3 times negative 2 to the second plus negative 4 times negative 2 plus negative 2. That's 18. Okay, this one's easy on division. You just make an underline, and then F goes in the numerator on top, and G goes in the denominator on bottom. And I'll be putting negative 2 in for the top, so I take 3 times negative 2 to the second minus 5. That gives me 7 in the numerator. 4 times negative 2 is negative 8, and then minus 3 from that's negative 11. Okay, had a lot of problems on the inputs. Okay, again, the little circle means input. So you start with F, just write it down. 3x to the second power minus 5. And then we will replace our x entirely. Shift the second power outside there, minus 5. Now we replace x with the g function, and that was 4x minus 3. I'm going to write plus negative 3 to help you out. Okay, now you got parentheses. You can't do anything to that. Those aren't like terms. Now your exponent. Well, now your second power belongs to more than just the x variable. So what you do is you drop your 3, make a parentheses without a power, and then a minus 5 after it. Now to find out what goes in there, you need to duplicate that entire expression and FOIL it. So I take 4x times 4x, and then I take 4x times negative 3. Negative 3 times 4x, and negative 3 times negative 3. So that's 16x squared, negative 12x, negative 12x, and positive 9. Well, that makes negative 24x, so I put in the parentheses 16x to the second minus 24x plus 9. Okay. All you do is take this and FOIL it. But you got to remember there's a 3 still outside of it and a 5 being minus. So the exponent now belongs to just the x, and that's good. Now multiply, divide. Well, I'd have to multiply the 3 times all this. So it's going to be 48x to the second minus 72x plus 27, and then minus 5. Okay, now adding just your like terms. X to the second, and then x. And then we need to combine these as like terms, and that's positive 22. You got to run through the PEMDAS when you're doing that. So 3 goes in for all the x's, 48 times 3 to the second power, minus 72 times 3, plus 22, and that's 238. Okay, now it's another input, but now it's the opposite way. We start with G. So G is 4 times x minus 3. And now I replace the x. There's no second power, so I don't need to put a second power here. I just minus 3. And then I put the f, which is 3x to the second power minus 5. parentheses, no, I can't subtract those. Exponents, yeah, I have one, but it just belongs to the x, so I don't need to worry about it. Multiply, yeah, you got to take 4 times this binomial here. 12x to the second minus 20, and then minus 3. Now add or subtract like terms. Negative 20 minus 3 is negative 23. Don't put an x on that, okay? And then I insert negative 7 into the expression. 565. Okay, now the next part. That's the input. Input's been done. Now come up with the functions separately. Now there's an expression that's kind of separated itself from the rest of the expression. It's like an expression within an expression. X minus 3 is my g. Now you write 2 and then put your square root. It's not a parentheses, it's a square root, and then that's replaced with just x, and then plus 6. That's it. Okay, find the inverse of the equation. First, you switch x and y. So x equals 3y to the second power minus 5, and now you isolate the y. Undo the minus 5, so plus 5. So I have x plus 5 equals 3y to the second. Now, does y have a multiplier in front? Yeah, it does. It has a 3, so you need to divide by 3, not 3y, 3, okay? Now, x plus 5, all divided by 3 equals y to the second. Remember, my job is to get the y by itself, okay? And then the second power, I can just square root. Now, the y will be by itself, and I put a square root over that. So y is equal to the square root of x plus 5 over 3. And then, I'm sorry, but I'm not going to give anybody a mastery until they do the story problem correctly. Especially C and D, okay? At a store, coats on sale for 30% off. You also have a $5 off coupon. Write an equation that shows $5 off the unknown price, which is X dollars. Well, X dollars, $5 off, that'd be minus 5. Put F parentheses X in front equals, put a 1. It's not hard. You just put F parentheses X equals. Next one, write an equation that shows 30% off the unknown price of X dollars, okay? Now, X is dollars and the 30 is a percent, so that needs to be a multiplier, but it's not 30. You got to say, okay, 100% of the price, take away 30%. That means I'm paying 70% of the price, so the multiplier is 0.70. And just put equals and then G parentheses X. Okay, now C and D are the ones that are not being done correctly by a lot of people. Compose your two equations together so $5 off comes first. Compose means you need two parentheses with X by itself and then the little blank circle. Now, X travels this way. It has to go to here first, so I put a 1 there and then here second. Whatever it wants done first is what you put in slot 1. Well, $5 off. Well, that was done on the F function. So F goes in slot 1. G goes in slot 2. Now, start with your G, so 0.70x. And you're like, well, I thought you started with $5 off. It doesn't matter. I set it up, so now I just work it through. You start with $5 off. That means X has to go through F first before it gets to G. But when I work it and simplify it, I start with the G, replace the X, and put your F, 1x minus 5. 0.70 times 1x is 0.70x. Then 0.70 minus 5 is 3.5. Okay, now this one. Slot 1, slot 2. Wherever I did 30% off, which is on this one, that's your G. That goes in slot 1. And F here. So, to simplify it, you write your F down, which is 1x minus 5. Replace your x. And the G goes in it, so 0.70x. So 1 times 0.70 is 0.70x, and I just put minus 5. Okay, and that's how it's done. If you have these flip-flopped, you're not doing it correctly because you're not doing the 1, 2 like you're supposed to. Okay, $150 code, so that means I put a 150 there, 150 there. So I take 0.70 times 150 minus 3.5. That's $101.5, $101.50. Okay, now in the second one, 0.70, 150 minus 5, and that's 100 even. So the biggest thing I need to see is that ends up being the answer for C, and that ends up being the answer for D. They can't be flip-flopped.